Thank you very much. Can you see my screen already?
Yes, we can see that.
Okay, then let's directly start into the action. So yeah, I'm Nigel, Sense AI mentor, and I will share with you how you can make your splats more interactive with automatic workflows and pipelines, and also how to use them in different engines like Unity, Unreal, etc., WebXR. And yeah, if you didn't register up to now for our upcoming hackathon before we SIGGRAPH in Los Angeles, you should scan this QR code right now and take your chance to still register. And additional, we will have more of these sessions available. So with this QR code, you will find our upcoming sessions. Also tomorrow, we will have a session about Pico devices. So you should definitely try to join that. So yeah, just a bit of context about what we built and why we built it. So in world models in general, there's 4 different type of information or levels of information, and most of them are partly or fully solved, especially visual side. So for example, you use a world model to generate a world based on the text prompt or image, and you get a visual world back, like a splat, like we already saw it. And additional, in the second layer, you can get geometric information about it. For example, the collision map, which we already mentioned before, which you, for example, get from different world models. And with that, we can also include a lot of physical interactions with the splat itself, collision with it, running through the splat without falling through the ground and things like that. But there's one layer which was missing long time, and that is the semantic layer, understanding what is really inside of the splat. So not like just visually, but really getting positions of different elements inside of the splat, combining this information into logical workflows, use cases, etc. And yes, we was getting asked by a lot of hackers at our previous hackathon, like how they can do that. And at that time point, sadly, there was no solution available. And we are really happy to share with you our new kit, which you can use already from today. And also we will provide to you on the hackathon. And like you can see here, basically, you just upload, for example, a splat into our API, which we will provide to you on the site, or you can also run it locally. And you will find the 3D bounding boxes of your splat, so that you can build based on that interactions or showcases of products inside of it, or yeah, all kind of stuff. And I'm really looking forward to see all the cool use cases you build with that at the upcoming events. And exactly, before I show you more information about that, I just wanted to share with you shortly how the Splat Analyzer really works. So basically, we have a pipeline of 5 different steps. First, we do a rendering. So basically, we place specific amount of cameras randomly inside of the splat. And these cameras we rotate in random angles, looking into different directions. So we collect a lot of data about the splat before we even start into the real work. And this rendered images of the cameras, including the depth maps which we get from these, we will send into a detection step. In this detection step, we will basically search for 2D bounding box detections. So in each image, we search for a 2D detection, just traditional methods like, for example, OL as a model, which is a zero-shot model, which means you don't need to train it for detecting a specific type of object, but you just give a different classes names like, oh, I want to detect plans, books, monitors, etc., and it can detect all of them because it was trained on a really big data set. And after this detection step, he will send both the data from the cameras, including the 2D bounding boxes from the second step, into a 3D model, which means it takes all of these detections and creates this 3D bounding boxes, which we saw before. And that is built, for that we use the Boxer net, which was a research project, they built this Boxer net, and we reuse that to get the 3D bounding boxes. And everything we do after that is clustering these bounding boxes together so that we get the correct position. And then we output to you a JSON file, which gives you the 3D position of the objects in the file, a label like monitor, plant, etc., and also the scale and rotation of the object. And yeah, just to show it a bit more visually, basically we just have a splat on the left side. We put it into Splat Analyzer, and we get a JSON file out with all the detections, which we can visualize in a lot of different tools. We have a visualizer already provided in our repository, like you can see on the right side, but you can also use any other engine because you have the raw data of the detections available. Exactly. And with that, I would like to jump into action to show you a bit practical what all of that means. So, like I already shared with you, that is our repository about the Splat Analyzer. And basically everything you need to do is just taking this URL, putting it into your Claude and telling Claude to analyze your Splat. As an alternative, we have here 3 different ways to run it, either directly on your Mac or your PC using NVIDIA GPUs, for example, or you can also host it as your own server. I would just share with you first hosting it as your own server. If you have a GPU server available, you could just host it as an application like that. You create an API key, which I already put in here, and you just upload a Splat, like this workshop file. And you give the classes which you are searching for in the Splat. You give extra information about it, and you just run the detection. As soon as this is done, you can basically just either download the JSON file to use it in your workflows, or you can directly view it here in 3D. I already opened the output of this one. So this one actually is this Splat we just downloaded from Word Labs, so it's compatible to that. If it's loading, you can see a short preview here. Yes, so it's just a normal Splat. And with our tool, we get basically bounding boxes of all the objects inside here, of your monitor, for example. You can also see the detections on the right side. For example, if I wonder, okay, where's this lamp? I can just click on this eye icon, and he will also show me where exactly these items are. Exactly. And with these bounding boxes, you could now build your own experiences. For example, I just built with Claude a small example here, and I just use a really simple prompt. Please build or use a Splat Analyzer to analyze my Splat locally. Use the Word Labs API to generate a Splat. Create a fantasy world where you need to have a portal and a door inside, and you need to run through the portal. And that's everything I just gave Claude. And that's the real advantage of Splat Analyzer, because not only you understand the Splat now, but also your agent understands it. And finally, our agent is the first time ever able to understand the real metadata of the Splat itself. I just prepared one example here. This is the local thing I built. I I didn't need it to do anything itself because he found this objects himself, the chest inside of this one, the door he found himself, and now he is already telling me the door is locked because I need to search for a key. I will click, I guess I'm not fully inside. Yeah, I will click on the box and I found the key and I jump in the next world. And all of this was completely autonomously built using just by the agent and word labs. He finds the position of this portal now inside of the splat using Splat Analyzer. And as soon as I'm close enough, he will tell me that I finished the game. Just one example how you could use that. Exactly. This is just the example I shared with you 1 second ago. So you can use your agent to fully generate the game. You don't need to position anything yourself. He can generate the splat itself using word labs, for example, and then find the objects himself inside of it and build experiences based on that. Another example built by Johannes, you can see here, one of the other mentors. He used our tool to find objects on a kitchen table, ingredients for a recipe, for example. You can maybe get information for a recipe, or like you can see the other example here from the sky, having scanned an entire city to count the houses, or actually there's some burned down sites as well. So maybe even scanning damages in there and marking that. So that is really practical. And the other use case we have is like a spatial semantic connection. So what Johannes tried to build here is having connection between each of the elements. So basically, you know that the table is on top of the carpet, for example, or that the Christmas tree is standing on the table, and getting these type of spatial semantic connections. I think that's a really cool use case and would really like to see more about that. Yes, if we're already talking about splats and practical use cases we can build with that, we also wanted to share with you Image Blaster, another project which was shared in the community showcase by Word Labs. And basically in Image Blaster, you can, it uses Tripo for 3D asset generation and Word Labs for creating an entire environment with a splat. And I will just directly share with you how that would look like. So it is using Fall AI in the background. And on Fall AI, you can, for example, use Tripo. So I just told my agent, like you can see here, that he should please use Tripo for 3D asset generation, and that he should take an image, which I generated. I will just show you shortly which image that was. Image Blaster, exactly. And you basically just put the image in the input folder here. You tell Claude to blast the image, and he will create an entire world out of it with usable 3D asset. So this is the input image I provided, like some sci-fi style room. And what Image Blaster was making out of that, you can see here. So basically, you have this entire 3D environment. I don't know if you can see my sound right now, but it's also creating using Fall AI ambient sound. You have objects you can move around freely, like this stack of books, for example, or this monitor, which you can see usually here on the right side in the console. So let's try to move it there. Exactly. And that's a really nice way of adding interactivity automatically to your splat and using Tripo 3D for real-time object generation. And yeah, this you can find here at GitHub under Image Blaster, or also directly under the community showcases on WordLab.